Hello, and welcome to Autology, the podcast that brings you the latest on automotive technology. Today's episode is called Mapping the Market. What direction are navigation systems heading? And you're here with me, Elisha Thakorlal, and today's guest speakers, Michael Harrell, who is TomTom's Senior Vice President of Engineering Maps, alongside S&P Global Mobility's very own connected car expert, Vivek Beriwal. Hello to you both, and thank you for joining Autology today.
Hello, thanks for having me.
Pleasure to be a part, Elisha.
Thanks for coming on. So, today's podcast is all about navigation systems and the wider development of software defined vehicles or SDVs. But if we step back a bit, the first question that I really have is 5G where it needs to be or where you expected it to be in terms of, robust global coverage, in order to facilitate navigation maps and other key features related to the SDV. So let's kick off with your views first, Michael, if that's okay.
Sure. 5G is not a limiting factor for all the advancements we're trying to make at the moment in the Western countries. Certainly, as we get to some of the not as prominent countries, it's problematic still. Clearly, the advancement of software defined vehicles and online first capabilities is going to struggle as a result of not leading in those expansions in those areas. I think there's still a cost problem. So it's not so much a bandwidth and latency problem as much as it is a how much data can you really still cost effectively move over this because these cars are becoming extremely rich with data. And so that's still, I think, a bit of the challenge.
Okay, understood. That's good to know. And Vivek, what about yourself?
I would completely agree with Michael here. I think a software-defined vehicle is anyways designed to be resilient, in connectivity challenged environments. So if in a worst case scenario, if GPS signal is weak or even absent, the vehicle can shift critical functionality to the edge inside the vehicle, that is, and use a layered approach by combining sensor fusion, edge AI, high resolution maps, and predictive systems to ensure safe and accurate navigation. And it can also fall back on multimodal sensing, that's combining data from GPS and the inertial measurement units, wheel odometry, and fusing inputs from various sensors and radar and lidars to estimate the vehicle's position. Lastly, I think preloaded high definition maps that can be stored locally can also help with navigation without needing a live internet connection.
Yeah, okay.
One thing I'll add on top of that, as I thought about it as well, which is advancing in the software-defined vehicle space, is vehicle-to-vehicle and vehicle-to-everything communication. So as vehicles move out of having connectivity but are still able to communicate with each other, that advancement's also going to enable a much richer experience than what we were able to achieve in the past.
Yeah, absolutely. And then map makers are also increasingly integrating information on features like, lane keeping, traffic, speed limits, all sorts of stuff. But this significant increase in data requirements, Michael, do you think that there will ever be a point where infotainment systems get so energy hungry that it will start to become a concern for an EV's power or range?
So not so far on the power consumption side. I look forward to that day. Right now, the biggest challenge is on the data consumption side. And again, it's really related to cost factors of how much data are you willing to consume from the sensors, store even on board, so that you have enough onboard storage space, and then what of that data are you willing to transmit over the cloud, all primarily driven on a cost perspective, and it's exponential, the data growth. It's incredible. And part of the reason, it's not just to help with our ability, for example, for navigation and autonomous and updates of software. It's also to drive deeper and richer analytics for the OEMs and other suppliers so that they can have a better understanding of how to continue to evolve and improve their products. So the more information you can put into the cloud, the deeper and richer insights you can get, the better you can improve your products. So there is a huge interest in pushing a lot more data, but we do still have constraints.
I completely agree with Michael again here. By and large, in-car navigation systems have a very minimal impact on EV range as far as power consumption is concerned, unless of course the vehicle is left idle with the system running for days or the software is poorly optimized. I think in-car navigation systems are not really a concern from a battery efficiency or range perspective. But yes, when it comes to semi or fully autonomous vehicles, they require high computational resources. Same thing Michael was mentioning, data consumption when running HD maps, perception and path planning. And this could in fact drain the EV battery fairly quickly. Yeah.
Okay, understood. And then, just for a bit of context here, what are the differing challenges of map development in an EV or electrified vehicle versus traditionally fueled? I mean, if any at all.
Yeah, so certainly EV adds some additional challenges. For example, the most obvious one I think is making sure that you have a better understanding of grade, basically the elevation. Are you going up? How much are you going uphill, downhill type of things? Because that affects range on the vehicle and therefore affects how you can continue to reduce range anxiety from the user and being able to know when they should charge. So that's a key advancement that's actively happening. In other aspects, I think that from a navigation or mapping perspective, there's not as much unique related to EV other than us making sure that we continue to evolve understanding the advancement of the infrastructure for EV. Clearly, there's a bottleneck in the consumer adoption as it relates to what we call range anxiety. How far can you go before you lose charge, and how long, and will you be able to find a charger that is available, that can accept your car, is in a safe place, things of that nature, and continuing to advance our knowledge of that infrastructure and the availability of that infrastructure is really important to continue to drive further adoption of the EVs.
Yeah, great points there. And moving on to the hot topic, that is AI. Thanks to AI powered map platforms, modern in-car navigation systems are really adaptable, i.e., they personalize navigation based on, driver behavior or preferences. They know frequently traveled routes. Like my car always seems to know I'm desperately in need to go to my local coffee shop straight after the school run, for example. But how do map providers like TomTom cater to so many automakers who are looking for distinctive and customized mapping interfaces and user experiences?
So it's a incredibly deep question that you ask. Let me start just kind of high level because why I say that is because maps is incredibly complex. The mapping industry has struggled for decades now in being able to innovate and advance because we have basically a few map makers out there. TomTom, a competitor of ours, Google, as well. These are the only map makers, and you have to go to them for a map in its entirety, and as a result, the maps can only advance at the speed at which these companies prioritize and have the resources to advance that map. And that's been super constraining. And then if you put your data into one of their maps, your data can't live in the other map. And so now all of a sudden, sensors built on different maps can't communicate with each other. It's a huge problem for the industry. It's slowed the advancement of autonomy in a significant way. There's a few years ago, a number of tech companies, including TomTom, came together and created this foundation called Overture Maps. It's ultimately creating an open data maps platform that allows the world to work together on the base map capabilities. The reason I went through all of this to get to why is an open map platform and open map data critically important for everyone, it's because of exactly what you asked is how do you allow your engineers and your data scientists, applied scientists to focus on the innovation? It's by not focusing on the core basic capabilities. It's not figuring out where the roads are and where the turn restrictions are. All these base capabilities that should just already be built into a base map. It's focusing on that next set of innovation and features. And it's all enabled as a result of this transformation that's happening in the industry where now 40 companies are all working together on the PACE capabilities, which is now enabling TomTom to work on advancements in these richer, deeper areas of features and map richness that are unlocking further analytics and autonomy and other things of that nature. It also then enables all of these vendors and OEMs to do the same. Focus on the things that are going to differentiate for their customers and advance for their customers.
Yeah, just to reiterate what Michael said, but I think big map providers like TomTom, they offer modular APIs and software development kits that allow automakers to customize all aspects of their interface and experience, including fonts, colors, icons, etc. And they can also include or exclude specific features like 3D buildings and EV routing or traffic layers based on their model tiers or use cases, and even integrate vehicle specific data. Then some map providers offer white label mapping platforms also, allowing automakers to completely rebrand the mapping interface and maintain consistency across their infotainment platforms, regardless of the underlying technology provider. TomTom, I think, is a good example. It customizes embedded navigation systems for each of Stellantis brands, from Peugeot across to Jeep. Yeah.
Yeah. Yeah. Okay. Yeah. Thanks for that, guys. And actually, on the point of OEMs, who do you think is leading the market in terms of, software readiness for navigation systems?
It's such a impossible question to answer by saying any individual OEM. What I will say, instead of naming an OEM, because clearly there's kind of two answers to this. There are certainly some OEMs that are moving much faster in adopting and innovating, and I think the biggest thing I would say that differentiates one OEM from another is they're changing how they internally work related to software-defined vehicles by recognizing that the vehicle is now defined by the code rather than the hardware, and how they structurally work and operate needs to change with that. And in the details, what I'm saying is, rather than being hardware and procurement driven, where engineer to engineer collaboration, architect to architect collaboration is sometimes stifled or constrained as a result of that way of operating and that kind of organizational structure. Those companies that have moved past that and they are allowing architects to collaborate early, they're reducing the complexity in their software stack by not going after many vendors to find the cheapest set of software components they can put together, where their software engineers do nothing but try to integrate all of those complex systems, but instead try to simplify to a few set of strategic partners that have deep relationships with their engineer and advance the technology. They're going way faster. I would say, on who's doing the best at this, clearly China, and the OEMs and the advancements coming out of China they are not constrained by the historical ways that we've done vehicle manufacturing over the past several decades. And so they've kind of reinvented how that looks, and they've reinvented how they operate, very much around software-defined vehicle type of advancements. And it's a difficult thing to change decades worth of organizational structure and ways of operating. And each OEM is at a different stage of that.
Very nicely put across. I think in terms of software readiness for navigation systems in particular, it's very, very difficult to name any names here. But again, if we talk about automotive and software in the same breath, then obviously Tesla comes to my mind. It uses a fully custom navigation stack, using Mapbox, OpenStreetMap, and proprietary routing that is deeply integrated with its autopilot and full self-driving. So yeah, Tesla system includes lane level guidance, real time traffic data, and predictive routing, all powered by its in-house software and AI. And if you add regular over-the-air software and firmware updates to the equation, you get one of the most advanced in-car navigation capabilities, like most other capabilities that Tesla offers. And another name that, if we just have to give another name, I think Mercedes-Benz is also fairly advanced in terms of the software readiness for navigation systems. it has a reasonably software ready and highly mature platform when it comes to navigation use cases, which is housed in its self-made MBUX platform and uses maps from, if I'm not wrong, from here as well as Google and in newer models.
Okay. And just on the flip side of that, Michael, which OS system, from like automotive Android or Linux, would you say is the most compatible or the easiest to integrate TomTom into?
We are finding that I wouldn't say so much one easier than the other. I think it's more of where are things starting to standardize towards. And certainly Android is becoming more prevalent in OEMs adopting. And so as a result, you're going to see a bit more richer and further advancements as a result of so many moving to adopting Android as their base OS.
Yeah. And one thing actually I'm interested in is what about car makers who are developing their own operating systems from scratch? Like, would it be easier working with a blank slate rather than almost retrofitting your navigation to existing software? Or would it be improved in terms of UI UX if TomTom was brought on in the early stages of OS development?
Yeah, so it's a very complex thing to answer. The challenge ultimately is it comes down to at what level do they want to integrate? At what speed do they want to deliver advancement? Certainly, we can give lower level SDKs and API capabilities that are just as easy to use with an OEM's personal OS system as it would be anyone doing anything on top of Android. Where it gets more complicated is if you want to just take kind of an off-the-shelf, more full-stack solution. That off-the-shelf full-stack solution would have to be heavily modified to be able to work into a unique OS. And so it really puts a bit more of the burden on some of those core functionalities to be developed uniquely for that OEM. Of course, as you mentioned, that also does enable the OEM to have a bit richer and more specific capabilities that they couldn't otherwise get with certain off-the-shelf things. So it's a bit of a balance. It's a little complicated to go into in a short podcast to the level of detail it would probably require. So I apologize for not an easy answer.
No, that's a brilliant answer. Thank you. And actually, going back to something that was mentioned before with automated vehicles, HD mapping has become the norm with the rise of automated vehicles. But what are the challenges? And Vivek, you can come in here. There's challenges in creating navigation systems for semi or fully autonomous vehicles in the future.
Good question, Elisha. I think creating navigation systems for autonomous vehicles is obviously more complex than for traditional cars. While conventional navigation is, about getting from point A to B, navigation for autonomous vehicles, it requires interpretation and prediction and acting in real time, all while guaranteeing safety. So autonomous vehicles, as we know, need, centimeter level accuracy, and standard GPS maps are not precise enough. So they obviously need high definition maps, which are costly in the first place to build, as they need constant updating and regional scaling, which is a bit of a challenge, particularly in semi-urban and rural areas. Another challenge I could see is that autonomous vehicles must fuse real-time sensor data from lidars and radars and cameras and all the hardware with static maps, and sometimes the sensor data can be noisy or blocked when it's raining, or say, weather conditions are not quite favorable. And another challenge that I can see is that navigation systems in autonomous vehicles require high computational resources also, which as I think we covered it earlier also, it could play some role in draining the EV battery, the data consumption part that Michael touched upon earlier. So yeah, these I think would be some of the main challenges in creating navigation systems for autonomous vehicles, but I'm sure there will be more.
Yeah. And would you agree, Michael, or do you have any specific examples of challenges that TomTom has or is yet to overcome for driverless vehicles?
Well, I'll fully agree with Vivek. In fact, his summary of some of those challengers are right on. And what I would say is, it's in fact where the most significant innovation is happening within TomTom. So let's take, for example, what Vivek mentioned about creating the level of richness in HD at scale and at cost where standard consumer grade sensors are not yet at the level of detail that's necessary for HD. So TomTom's been driving for over a decade these survey grade vehicles, and we have an enormous amount of coverage in all of the Western countries. But what has been a blocker is that you can't redrive to continue to make that fresh. It's very expensive to redrive survey grades everywhere. I don't know if we remember the day when Google was driving all of these cameras around and you saw a huge fleet of them in every city. That's since died down because it's just not cost effective. The advancement that has happened is being able to identify, instead of continuing to redrive, identifying where the road is changing, and more importantly, what of the road has changed without having to do the redrive. And that's where the fusion of multiple sensors comes in. And when I mean multiple sensors is you take the survey grade data, say even if it's driven 8 years ago, and if you have a bunch of consumer grade cameras continuing to confirm that in fact the road has not changed from what the survey grade vehicles have seen, you can continue to use the higher reliable survey grade data. And in fact, even when it's changed, oftentimes the curb or certain poles or traffic signs or other aspects of that scene have not changed, and you can use the data that hasn't changed to correct the accuracy of the other sensors and ultimately build out an HD map. And so TomTom is launching actively right now something which is basically our ability to scale on all roads where there is an SD navigable map, an HD capable map. Now, of course, it's going to degrade over time depending on the saturation of sensors. So where we have survey grade coverage over the past decade and reasonable saturation of consumer vehicles, we're able to maintain an HD map. And as that saturation falls off, we would still have an 3D map for visualization and other capabilities to keep a seamless integration in the navigation experience. But we would fall off on being able to supply HD like functionality for autonomy. And that is a huge breakthrough because what that does is it unlocks our ability to advance autonomy outside of only motorways or only predefined regions in an urban setting where you're seeing Waymo and other operating. And that's unlocking a significant advancement in further scaled autonomy, which will be coming out in the coming years. And so that's super exciting. The actual vehicles on the road coming out in a couple of years, not the advancement of the map.
Yeah. Oh, that's interesting news. Just wondering here, as a follow-up to that, is it at all viable to utilize the cameras, that we all have in our cars for insurance or crash purposes, to utilize them to help mapping, or is that just not HD enough?
They do not, as Vivek said, they do not yet have the level of positional accuracy that would be necessary to build a fully HD map on its own, capable to truly advance autonomy. Although, to be clear, there's plenty of marketing material out there of companies trying to pitch that, in fact, they are doing that. It is not the case when you look further into the details and see the level of quality. But clearly, it is a fundamental important, particularly for ensuring the freshness of the map.
Okay, understood. And actually, one thing I'd like to know is your take on embedded navigation via a smartphone. I mean, we all remember the days of using, a separate sat nav. We even called it the TomTom, even if it wasn't one of your devices. It was like powered by the cigarette lighter, and rather than safely stuck to the windscreen. How can TomTom compete with consumers nowadays who prefer to
Yeah.
use their phones with, Google Maps or Waze rather than deferring to your built-in navigation?
Yeah, the thing I would say is it's going to change significantly because there is a massive change happening in the automotive industry that we've never seen in our lifetime, both because of autonomy and because of EV. And let me just explain the two reasons why. First, EV changes how cars can be designed. Because you no longer have to have this big, huge engine compartment for the combustion engine. You can have these flat batteries. You can see designs of cars evolving in ways that we could never have predicted before. and they're going to design them in ways that allow for a more comfortable living-like experience. And with the advancement of autonomy, where you no longer have to operate the vehicle, so the vehicle is no longer being designed to help a human operate it because the vehicle is going to operate itself, it's going to evolve to being designed to provide for entertainment and comfort experience. And so what you're going to see in the future is these vehicles are going to be more of a living third kind of living room type experience to bring people from point A to B, and people are going to interact with their vehicle in a very different way. The second thing that's going to be significantly advanced, that allows significant advancement that will engage people with the in-vehicle systems where they used to stay very heavily embedded with their phone is, again, the advancement in AI and specifically in LLMs, your ability to have natural conversation as your interface to your computers and to your vehicles. Once that occurs, having a natural interface to your phone, to your PC, or into your in-car nav system or your in-car system is just going to be as easy. So it won't feel like, as a user, you're having to change your input experience to something that's kind of foreign. You'll just get into your car, you'll talk to it. The car will be able to, in fact, respond in a more accurate and better way because it'll understand your context. Because where you're talking to a phone or to your computer, it doesn't know what you're trying to do because you're doing many different things. When you're in a car, it's more specific. It knows you're in that environment and you're doing certain things, and so it's going to be able to be better context aware of what you're trying to achieve, therefore better able to give you deeper and richer responses. And so, in fact, we're going to see a massive evolution in how vehicles are engaged with, and it's going to be a very opportune place for TomTom as well as for the automotive company. Super exciting stuff.
I think Michael's covered almost everything from a technology perspective. I think it would be also interesting to know what's going on the consumer side of things. So I would like to share a couple of interesting snippets from the most recent S&P Global Mobility's Connected Car survey. Enhanced in-vehicle navigation emerged as the number one feature in the survey that consumers want in their next vehicle. However, that was followed by smartphone integration in second place. And the reason why smartphone integration was rated so highly is because the survey respondents felt embedded infotainment and services were far too costly. And if you consider that they already had similar apps and services on their smartphone, they preferred phone projection as an alternative. And the Chinese drivers had some of the highest use of embedded connected services. However, this was mainly via free trials as opposed to proper subscriptions for navigation packages. So yeah, it's quite interesting.
Yeah. Okay, understood. And actually, just before we wrap up today's episode, on the point of China, you mentioned Vivek, it would be interesting to know, Michael, how TomTom is staying competitive in that market, given the dominance of domestic map makers like AutoNavi, for example.
Well, I would say rather than competitive, collaborative. We have deep and collaborative relationships with the Chinese vendors and suppliers that allow us to be in a strong position to help enable them to continue to advance and move fast. Clearly, a map in China itself is complex and not something that we're in a strong position to do due to political and other reasons for outside companies to have a competitive opportunity to play within the domestic market of China. So that's not a position for us at the moment. But as far as partnering with all of the key Chinese vendors and suppliers and OEMs, we are deeply in with them and working on some great advancements.
Wonderful. Great. Thank you. Unfortunately, that's all we have time for today. A big thank you to you both for joining Autology.
Thanks for having us.
Thank you. Yeah, thanks very much.
And thank you to all you listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our autology@spglobal.com email, and you can find out much more at autotechinsight.spglobal.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest Autology podcasts, and we look forward to you joining us again in the next episode. Bye for now.